Hello, Chris Sexton here with Team iKON. Welcome to my Nitro Gov setup basics video. I get a lot of requests for the differences between electric Gov setup versus Nitro Gov setup. I have spent the last few months tweaking and tuning and really getting a feel for the ins and outs of the iKON Nitro Governor, and I think I am ready to film these two videos. Video number one tonight, we are going to take my N5C, as you see here, and we are going to do a basic Nitro Gov walkthrough. Talk about setting the endpoints, talk about the RPM sensors supported, the adapter necessary to use certain RPM sensors, as well as take you through the basics of the setup itself. There will be a second video probably filmed next week on advanced tuning of the governors. The nice thing about that is that video will cover both electric and nitro. The basics are there for the same for both. So tonight we're going to talk about setting up the Nitro Gov. I'm going to go ahead and cut the camera. When I come back, I'll have the camera zoomed in on the N5C a little better. We'll talk about RPM sensors. Okay, here we go. As you can see, I'm doing this video with my Synergy N5C, running an iKON governor. Take a minute to talk about RPM sensors. On this particular helicopter, I am using the Align magnetic RPM sensor. The nice thing about the Align magnetic RPM sensor is it already has the correct JST plug on it. It's a direct plug and play. There's nothing to rewire, there's no adapters necessary. It'll just plug in and work. I have tested this though with the Futaba magnetic RPM sensor as well as the Spectrum backplate sensor. Both work fine. The only difference is with the Futaba magnetic RPM sensor or the Spectrum backplate sensor, you need one of these. Most RPM sensors have a servo type plug on them. The iKON Gov does require a JST plug, so you pick these up. A lot of places carry them. I got mine from Heli Direct. This is what they call a servo to micro JST. This particular one was 99 cents at Heli Direct. I don't know if it was on sale or if they had limited quantities, I'm not sure, but if you do a search for servo to JST, you'll find this part number. Grab those while supplies last. They do have another one. It's $5.99. I think it's just a name brand manufacturer and has a higher gauge wire maybe, but I'm using a bunch of these. They work great. So again, Align RPM sensor, you don't need the adapter. Spectrum and Futaba sensors, you will need the adapter. Nitro 101, if you're using a magnetic sensor, you want to make sure you install the magnets into the bell or the fan, wherever your helicopter may have the magnets. Make sure you have a positive pole on one side and a negative pole on the other. The real easy thing to do there is to take the two magnets, and I apologize, I don't have any spares to show you this in video, but take the two magnets out, let them stick together. Magnets, opposites attract, so you now know the two touching surfaces, one's a positive, one's a negative. It really doesn't matter to us which one's which. I take a red Sharpie and then mark the outside, the non-touching sides of the magnet. Now I know I have a positive and negative pole marked. Put them in my helicopter with the red marks facing up, and now I know my polarity is right on the magnets. One quick tip, if you're having trouble getting RPM readings out of your iKON, double check this gap is close. These sensors are not overly powerful. If you don't have this gap just about paper thin, close as you can get it without it touching, it's likely that you're not going to get an accurate read. So if you're having RPM holding problems in hover, or if the governor is not engaging, it's probably because it's not seeing RPM. So keep an eye on that. What I'm going to do now is I'm going to cut the camera. I'm going to flip the helicopter around. We're going to talk about a couple of quick things on throttle servo geometry, and then we'll start the software. Okay, I went ahead and flipped the helicopter around. We're now looking at my throttle linkage. I get into a lot of debates with guys on proper geometry. Basically, for the governor to work effectively, you need, just like a cyclic servo or a rudder servo, it needs to have good resolution, meaning it needs to be able to make minute and major adjustments to movement to fine-tune the throttle output. I see a lot of guys in the field complaining that they're not getting everything they should out of the governor. They can't get, when they go to do the endpoints, they can't get all of the throw. It's not going all the way to full. 9 times in 10, the problem there is they don't have these horns set up properly. Basically what you want to do is, I always recommend whenever possible to use an identical size horn on both the throttle servo and the carburetor bowl. And then you want to make sure that the balls are relatively equal distant from the servo point. So basically, in my setup, every minute movement of the servo, I get an equal movement of the throttle bowl. The other thing that does for you is, by using a longer arm, you can always adjust your throw. If you can't get all full, you just go to a longer ball on both sides, and you get a further throw. The other thing to keep in mind is to make sure when you center your throttle servo, you center the carburetor bowl and then attach the arm. So that's neutral center on the throttle servo is 50% throttle on your carburetor bowl. This is going to be extremely hard to see on the video. I will try, but basically what you've got is, on the actual carburetor bowl are notches. You have a notch for closed and a notch for wide open, and then a few notches in the middle. The very middle notch is almost always 50% throttle. So I put the carburetor bowl there, mount my arm, center the servo, make sure the arms are parallel, and that's going to give you good geometry, equal throw. It also makes it real easy to adjust if you have a problem with endpoints. Again, that's Nitro 101. I'm not filming this video assuming you've never flown a Nitro before, but I like to cover the basics. I'm going to go ahead and cut the camera and move over to the software itself, and then I'll take you through the Nitro setup. Okay, as you can see, we're now set up in the software. I'm not showing the helicopter right now because what's happening on the helicopter is pretty easy to explain without seeing. I really want you to see what I'm doing in the software. Two things that I want to talk about first. First and foremost, before you can begin to calibrate the throttle and the governor, you need your radio to have a linear throttle curve in normal mode. You can't have any weird V curves, you can't have any flat curves, this needs to be linear. The second thing you need to do is go to your transmitter tab, which is where I am now, and look at the throttle. Make sure your throttle is properly calibrated to the transmitter. Right now my throttle is at mid-stick. I want to go all the way to low. Adjust your servo endpoints until you got 0 there. All the way at full. Again, linear curve. I have 100%. My iKON and transmitter are now calibrated appropriately. I will after this point forward, you do not touch the servo endpoints in your radio. The radio is now calibrated to the iKON. Now, just leave that at mid-stick so you don't bind your throttle servo. Next thing I recommend, particularly on models that have been flying, or if this iKON has been reused from a different bird, jump to your banks screen and make sure you're in a flight mode that use governor is turned off. That is incredibly important. If you leave that box checked, while you're trying to set the endpoints, the governor is going to be interacting with the throttle and it's going to cause you headaches. Just make sure your use governor is turned off. It defaults off on new models. If it's a brand new iKON, it'll be off already, but check it. Just be safe. So now we have a linear throttle curve for my radio. My radio is at mid-stick. The radio is calibrated to the iKON, and we are sure governor is turned off on this bank. We are now ready to play with the actual setup. First thing you're going to need to know, just like an electric, you need to know the main gear ratio. If you don't know the actual ratio, but you do know the pinion and main gear count, you can click on this. Let me drag this down to view. You can click on the calculator button, input the values of your pinion tooth and your main gear tooth, and it'll do the math for you. I happen to know with the Synergy N5C that the gear ratio is 8.5 to 1. We talked about already the importance of the difference in sensing divisor. 99.9% of the time on a Nitro helicopter, that's going to be 1. If you accidentally glue your magnets in, both positives up, you're going to need to make that a 2. That way it knows that it's going to see 2 pulses from the sensor for every 1 RPM. If you can get the magnets out easily without destroying something, I would recommend flipping one. But if you're not getting the RPM reads, that's the thing to check. If you mistakenly glue both magnets with a negative pole up, depending upon what sensor you're using, you may have to dig one out. I'm not sure. Personally, I've not run into that. Someone who has can correct me if I'm telling you wrong, but I'm pretty sure if you end up with both negatives up, with the Align RPM sensor anyway, you have to flip one. But someone will correct me if I've got that wrong. We're going to talk about the speeds a little bit later. The next thing we're going to talk about is the gain. The default governor gain is 50%. I strongly recommend you try to fly it at 50%. The Corrado and Thomas and the team have put a lot of input, a lot of thought into the defaults. Personally, I think for most pilots on the market, the default gains are great. Select the model size, select your flight style, and go fly. Depending upon your setup, though, depending upon how hard you are on the collective, how hard you, what kind of throttle servo you have, what motor you're running, how big your disc is, those things are all going to impact the gain values. But try it at 50% before you before you adjust it. It will fly at 50%, 99.9% of the time. The next step is going to be throttle endpoints. As you can see, my throttle stick is basically at mid-stick. I've already calibrated the radio to the iKON. So I got half mid-stick in the radio. I'm showing 50% on the screen. That's perfect. What I want to do now, this is a good time to verify your linkage. iKON has now sent a center signal to the servo. This is a good time to put your carburetor linkage at mid-stick at 50% and your servo horn at square. Get them perpendicular to each other. Good time to get everything centered. After you've got the linkage centered and your square, and you have the balls in the manufacturer recommended locations for travel, you're ready to start trying to adjust the throttle travels. What you want to do is I start by going low. I slowly bring my throttle down. Normally, you're probably going to either bind before you hit low stick, like mine is now, or it's going to not go all the way. What I can do here, I'm adjusting the low side throttle, minimum throttle. So I'm going to put that on low. I'm binding a little. So I'm going to increase my minimum travel. Decrease the minimum travel. The plot positive, it's a little confusing. It'll make sense when you look at the heli. I'm just bringing up my minimum throttle a couple of clicks until I'm closing the bowl all the way, but I'm not binding. So now my low side throttle is calibrated. All the way down, 0 on the radio, carburetor bowl is closed. Now we're going to do it the other way around. We're going to go up, and again, go slow, don't just slam it. You don't want to break you bind your servo. In my case, I am binding before I hit the top. So I'm going to decrease my top side throttle until I stop binding and I get movement. And then come back to where it does bind. And away we go. So now I have that easy. I've got my maximum throttle set. I got full throw. Carburetor bowl is wide open. Hash marks lined up with the full. No binding in the throttle servo. Mid stick is still registering halfway through the throttle, which is perfect. And 0 throttle closes the throttle bowl without any binding. It really is that simple. No firing up the motor and checking the way it runs. That'll come later. This step is simply to adjust the throttle servo travels. It's that simple. Now I have 100% use. I can use every bit of carburetor travel I have, and my servo isn't binding. Now, a couple things to talk about there. I'm not surprised it was that easy with mine. I've already had the growing pains of, well, I started with the balls in the middle, and I couldn't get enough throw to make the carburetor ball open all the way. So I had to bring the servo balls out a little bit. I've had it the other way around. One bird, the servo balls all the way out. It bound way before the full travel. And I couldn't get enough minimum adjustment in the radio to make it work. So I had to bring the balls in. You may have to play with it. Most of the manufacturers will give you a recommended starting spacing. So start there. You're usually pretty close. But don't be surprised if you have to adjust the servo balls a little bit. Quick thing on the software real quick. Now that we have the minimum and maximum throttles calibrated, we're ready to tell the system the desired RPMs. Just like on the electric, if you watched my electric tuning video, the iKON gives you the ability to predetermine the RPMs. You don't have to slowly play with a tack and your throttle curves to find the spot that gives you the RPM you want. You just tell the system, it does the math on the gear ratio, sees the RPM reading, and tells you where you're at. In my case, on my N5C with the OS55, 2150 is about the best I could do without really stretching the motor with an 8.5 to 1 gear ratio. I know guys that do 2250 on a 600. In most cases, depending upon your gear ratio, that's really stretching the power band on the motor. And not only is that hard on the motor, you're not going to have real great governor performance. If you don't have some overhead in the motor, if it doesn't have some room to go to power through a maneuver, the governor's going to sag. So check your manufacturer's recommendations. Go onto the forums. If you're flying an Align 600 or TSA Infusion, look at the literature. Look at the manufacturers. Talk to the other reps. Talk to the other pilots using them. Find out what other guys are using, and use that as your starting point. You can really have a lot of adverse effects on the governor performance and the motor longevity if you try to run an RPM that just winds it way out. Okay, so we have the gear ratio set. We have told the system what RPMs we want to run. In my case, 1900, 2000, and 2150. We have set the throttle travel. We are now ready to configure the transmitter to request the appropriate RPMs. This is done exactly like the electric. Now that the transmitter is programmed to the iKON, to get 1900 RPM, you put a flat 30% curve. To get 2000 RPM, you put a flat 70%, 60 to 70% curve. To get a flat 2150 or speed 3, you need a flat 100% curve. Now, this is where it differs from an electric. We've calibrated the throttle endpoints so that 0 is closed carburetor bowl. That's your throttle cut. When you're configuring your transmitter, and this part will take a little bit of play, for lack of a better word, we're going to need to adjust the normal curve so that I have my low value isn't 0. It needs to be a few percent off 0 so that the motor can idle. And this is really where trial and error comes into play. You're going to have to try it. Give it a couple percent, watch the throttle bowl move a little, try to start the heli. Give it a couple more, find that spot where it idles. I strongly recommend you make the point it idles your 0% on the transmitter. I'm going to go ahead and reposition the camera so hopefully you can see my throttle bowl as well as maybe be able to see my transmitter a little bit, and I'll show you what I'm talking about. Okay, I can't find a good angle to let you see my radio too, but seeing my radio isn't really as important because it's going to vary from radio to radio. But what I like to do is, you can see as I give it throttle, you can see the throttle bowl moving. Okay. Again, this part varies from radio, helicopter to helicopter, throttle servo to throttle servo. What you want to do is increase the 0 value on your linear curve a couple of percent until the throttle bowl moves. I recommend starting at about 5%. Now, try to start the motor. See if it will idle there. If it will idle, is it too high? Is it too low? Probably a good idea to have the blades off for this so you don't smack yourself in the head. Once you get a feel for your helicopter, you'll know where to go once you get a feel for the motor. But it's helpful for the first time you set it up to adjust that value slowly until it gives you a good idle. In my case, on this motor, it takes 10% in the radio for it to idle. The next thing you need to do is go over to your hold in your radio. You want to make sure your hold is also a high enough value that it will idle. Otherwise, you walk out the line with hold on, it's not going to idle. In the fine-tuning adjustment video, we'll talk about programming bailout. Since that's a throttle and iKON function, it really doesn't matter. There isn't much difference between Gov electric and Nitro, so I'm not going to talk about that now. But for purposes of flying it, make sure the governor's working, tuning the governor. Make sure your hold percentage and your normal starting low stick percentage is the same. So when you flip into hold, you get no movement. Again, I've already been through the trial and error. I know on my helicopter, 10% on the normal run, it'll idle. Now all that's left to do is to go into the radio and program the throttle curves. Important to note that you need to go back to the software, go back to your banks, and turn the governor back on. If you forget to do that, when we set the throttle curves in the radio, it's actually going to give you a 30% curve or a 70% throttle or 100% throttle. You're not going to get the governor function. So don't forget to turn your governor back on. Now I'm going to cut the camera, program my radio, and I'll be right back. Okay, I now have my transmitter programmed. My normal curve looks a little different. Again, my normal bottom stick, 0 throttle, 0 collective number is 10. That's the number through trial and error I have proven this motor will idle at. My second point on my curve is 25. The reason for that, the iKON does not actually engage the governor until it sees an RPM request that will equal more than 50% throttle. So what that means for you, depending upon the humidity level of the day, whether or not it's the first run of the day or not, you may have to feather the throttle a little to get it to start. By not jumping straight to 30 on my second point, I have a little bit of movement off center, off 0, to help feather that throttle. I can use a little bit of trim if I want, just to help adjust the throttle to get it running. That's pretty common. I know a lot of guys do it that way. If you would rather just have a flat 30 normal, so you have full collective, full bang, you want to have three D'able head speeds, that's fine. You do the same with hold. It just gets tricky to do that with hold if you got bailout set up later. So your call. I like to start the helicopter without hold on, so my 0 stick, so I can use the throttle stick to feather it if I need to. We talked before about how to make the radio request the RPMs. Again, my normal curve is 10, 25, and then everything above, everything in the positive pitch range is 30%. My idle up 1 is a flat 70%, and my idle up 2 is a flat 100. So basically what that looks like is, you can see here, the governor is not engaged. My stick is at 0. As I bring up, you can see the throttle coming up. Nothing's happening here because I haven't reached a high enough on the stick for the governor to engage. But I did move throttle a few percentages, you can see there. So I've opened the bowl a little bit to help start the motor. As I bring my stick up and it actually gets to where it's requesting more than half throttle, the governor engages and it takes me to my 1900. If I want, and now everything, I can fly, all my positive pitch, the governor is going to hold 1900. When I flip into idle 1, I'm now broadcasting a flat 70% to the radio. Therefore, that's requesting speed 2. Now the governor is going to increase speed to 2000 RPM and do everything it can to hold that RPM as you fly. Same thing with 3. My idle 3, or idle 2, speed 3 is a flat 100%. That is telling the governor, I want you to hold 2150. It will now speed up to 2150 and do everything it can to hold it. That's the basics of Nitro Gov setup. At this point, you should have test fired the motor with no blades to find that low point that the throttle will run at. We've set your hold to that same percentage. As you can see, in iKON's world, it equals out to be 9%. So the motor will slow down, You can auto-rotate, you can land, you can shut down the motor, whatever you want to do. The very last step is to program your throttle cut. And this really is as simple as finding whatever function your radio has for throttle cut and setting it to 0. Because we already programmed the 0 endpoint to be closed throttle. So it's real easy. I know a lot of guys who will try to adjust their ATV so that 0 is actually idle, and then they put negative numbers on throttle cut to get it to close the throttle. That works too. I just think it's easier to remember. 0 is idle, throttle cut kills it. That's just my preference. I went through that a little bit fast. You may need to watch a couple times. I apologize. But remember, there will be a follow-up video talk about the advanced menus and the gain adjustments. I strongly recommend you try flying at 50% before you adjust anything. I'm sure there'll be loads of questions. Feel free to hit me up with PMs or emails. Post on the forums. I check the forums regularly. I have a job that has me in front of a computer, so being on the forums is easy. I'm more than happy to answer your questions. I hope this video helped.